Everyone, so welcome to my YouTube channel. So today we are going to see first lecture on Riemann still jet integration. Okay, this is new topic. So this is very similar to Riemann integration. Only one thing is the difference. We will take difference with respect to monotonically increasing function. Okay. So let's start today's lecture now. Okay. So let P is equal to AX naught, X1, X2 up to Xn is equal to B. Be a partition of closed interval A. So we are taking here B is greater than A always. Okay. In our lecture, we always consider B greater than A. Okay. And alpha closed interval AB to R be a monotonically increasing function. Increasing function. We write delta alpha I is equal to alpha xi minus delta alpha xi minus 1. Okay. So alpha is a monotonically increasing function. So therefore this is non-negative. So this implies delta alpha I is non-negative for I goes to 1 to up to n. Okay. Okay. So definition. Let F closed interval AB to R be a bounded function and alpha closed interval AB to R be a monotonically increasing function. Okay. For a given function, P is equal to AX naught less than X1 less than X2 up to Xn is equal to B. We write UPF alpha is equal to summation I goes to 1 to n capital Mi delta alpha I. Okay. This is called upper Riemann still jet sum or upper sum of f with respect to alpha and p, because alpha is monotonically increasing, p is a particle. Or we can say it simply upper sum or Darbox sum. We can also say it upper sum or simply upper Darbox sum. And what is MI? Capital MI is nothing but supremum of f, where x belongs to xi minus 1 to xi close interval. Okay. Now, and we write and we also write LP f alpha is equal to summation I goes to 1 to n small mi delta alpha I. Okay, this is called lower Riemann still jet sum or lower sum with respect to lower sum of f with respect to alpha and p. So we can say it's just lower sum, or we can say lower Darbox sum. Okay, the Darbox lower sum. Okay, so we have what is small mi? Small mi is nothing but infimum of fx, where x belonging to closed interval xi minus 1. Okay. Okay. Now note that for any partition P, we have LPF alpha is always less than UPF alpha, that is less than, okay, m times alpha B minus alpha A, and that is less than m times alpha B minus alpha A. Okay. They have capital M and small m are supremum and infimum of f on closed interval A. Okay. Let's prove it how it will work. Proof. we know mi always less than, so mi, small m is infimum over closed interval with AB, and small mi is infimum over smaller domain xi minus 1 to xi. So it will be, these can be greater also, but it will be less than corresponding capital Mi, and capital M will be larger. Okay, because M is supremum over closed interval. So multiplying both the side by delta alpha I. So what we will get? Now taking sum. If we will take sum, M will come out delta alpha I. Capital Mi will come out. Okay. Now what we will get? Summation delta. What is this? This will be nothing but, after solving it, what you will get? Something will be cancelled out inside this, and it will be nothing but alpha b minus alpha a. Okay. And this is nothing but LPF alpha. And that is less than, what is this? UPF alpha. And that is nothing but, after solving this, you will get at this, you will get this. Okay. So this is the proof. Okay. So LPF alpha is less than UPF alpha. Okay. And so UPF alpha is less than capital M alpha B minus alpha A, and LPF alpha is less than small m times alpha B minus alpha A. Okay. So today's lecture of this, if you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. Thank you very much for today's lecture. Thank you very much.